The confidence interval for the difference in population proportions. Independent samples of 325 adults and 350 teenagers. 175 adults and 224 teens indicated they liked the show. So P1 is the proportion of adults watching the show who liked it. P2 is the proportion of teens. So P1 is adults, P2 is teens. So we have 175 out of 325 liked it, and 224 out of 350 liked it. Now when you work these problems, you should read it carefully, because along the way there have been some problems that gave the information in terms of whether they liked it, but yet asked the question of who didn't like it. So you got to watch out for how is the question worded, because sometimes they'll give you information one direction and ask the question backwards. So just be observant, okay? So 95% confidence interval for P1 minus P2, okay? So our test statistic is the difference in the proportions. So that's 175 over 325 minus 224 over 350. Dividing, we get 0.5384 minus 0.64. So our test statistic is negative 0.1015. Okay? That's what that is the difference of these two proportions. But, okay, so the margin of error, remember for confidence intervals, see we're doing a confidence interval here, so that always starts with a margin of error, which is always going to be your Z or T or whatever other letter you got to work with, times the standard deviation, or the standard error. So the difference of proportions does use the Z test, the Z-score, okay? Proportions uses the Z-score of alpha over 2, which is the same as we've done every time. But now here's the formula for your standard deviation, which is sample P1 times sample Q1. And Q is essentially the complement of P, so it's 1 minus P, over the sample size 1 plus the same information for sample 2. P2 times Q2 over N2. Now, we do have to make a disclaimer that when you multiply your sample size times your proportion, or by the complement of your proportion, all of these values have to be at least 5 or greater than 5. So if you find your numbers, P1, 175 over 325 is 0.538. Q1 is the rest. The 175 from 325 is 150. Also in the decimals, these two numbers should add up to 1. So 1 minus 0.538 is 0.462. And the first sample was 325. And then P2 was the 224 over 350. Q2 is 1 minus that value, which is 0.36. And N2 was 350. So that's what we have to plug in here. But first, let's just make sure that N1 times P1, there's N1 times P1, is more than 5. So yes, that's 174. The next one's 150. The next one's 224. The next one's 126. Okay, so yes, these are all big enough. Once in a while, if you have a very small P or a very small N, then it won't work. This won't work out. And you cannot you cannot work with this stuff. You can't do either a confidence interval or a hypothesis test when you have too small of a P or too small of a sample size. Okay, so plugging in our Z for the 95 confidence interval, that's 0.025. For the two tails, we get Z of 0.025, which is 1.96. And it would be useful to you to memorize the Z-scores for 90%, 95%, and 99%, since they're used quite often. Okay, recommend you memorize those. 90% is 1.645, 95 is 1.96, and 99 is 2.67. 2.75. Oops, you better plug that into Alex and check. So here's our formula. Critical Z times the square root of, so here's my square root. Now the explanation in Alex used the P and Q for the first sample as fractions and everything else is decimals. So you see this looks a little different. I have calculated it and used those decimals all the way through, just because I think it makes more sense. Okay, so then Z, the critical Z was 1.96 times the whole big square root. So we have 1.96 times, and then of course I don't really have a symbol for that big square root, so I just SQRT times, and calculating 0.538 times 0.462 is 0.2486 over the 325 plus, and multiplying 0.64 times 0.36 is 0.2304 over the 350. And then just doing these calculations and trying to do them one step at a time for you, we get a margin of error of 0.0742. So that is now added and subtracted from the difference of the two proportions. Remember on the last screen we got negative 0.1015 for the difference of the proportions. So we subtract it for the lower limit and we add it for the upper limit to get these two values for our confidence interval. Okay? I know it's a ton of information for me to throw at you, but the idea is that this is all recorded, so when you hit these problems, then you can go back and spend some time looking over it again when you're actually doing a problem that you need to remember, and then you have this as a resource. Okay? The only reason that I feel like I can throw it at you so fast is because I know it's being recorded and you can go back and look at it. Are there questions? The confidence interval for proportions. Actually, I'm going to say difference of proportions.